go. All right, it's review day. If we start, so we are moving. We don't get through enough, fast enough, put it that way for you guys. You know, tell me, okay, let's jump to something else, but you know, kind of go a little bit of everything and keep try to get through everything. So way back, beginning of the chapter, find a couple solutions, find 3 solutions. Here's 2 different equations. The idea is for you to pick some numbers. Some of the problems, they actually tell you numbers to put in, you know, but here's where I've said, pick anything you want, stick in for the X, but then find the Y. So find 3 ordered pairs. Same kind of problem as when I put a fraction in. There was sort of a suggestion, you know, what kind of numbers should you pick if you're going to work with the fraction for the X values. Let my kitty out. See how that goes. We'll see what maybe I should just say, is that any issues with that? You okay with that? I know that's kind of depends on what you get if you do it, right? My thoughts there were always pick some easy numbers. Doesn't have to be complicated. Just looking for 3 ordered pairs. Any X value crazy that you might come up with, you can plug in there, and then you have to calculate or move things around, find the Y value. So
could I give you some examples of what I used?
what do you want to do? Yeah.
Okay. So my coach suggested some good ones to use are 0, 1, and -1. So that's what I went with.
Yep. That's our easy. That's when I say, you know, pick some easy ones. That's about what I do too. I like
Perfect.
to pick one -1, you know, just because. Yeah, so now you put those in for the X value.
And can I tell you what equations I wrote out? I just did the Y equals 3, and then in parentheses 0 minus 5, and that is how I got -5 for my answer.
This one.
Yes. And then for replacing the X with 1, then I did 3 times 1 minus 5. I ended up getting Y equals -2.
So 3 minus 5 at -2?
Yes. And then for replacing the X with -1, I did 3 times -1 minus 5. I ended up getting -8 inevitably.
Yeah, get my negative sign in there. Oops. All right, too messy. Where's my right? Anyway, I like those. Those are all good. Now be careful if a problem asks you then to present them as ordered pairs, and you've got to go back and say, all right, -1, -1.
Yes, yes.
Right.
And that feels really comfortable, you know. At least I can remember those are the X and Y's is there.
So that's the process, right? Pick some numbers and then carefully plug them in and do the calculation. Let's just say, what numbers might you pick for that one? Maybe we'll do them, maybe we don't. See how you guys feel about that. What numbers might you pick to plug in with that fraction? Why do I
picked 0, 5, and -5.
You understand what she's doing there? You know, picking numbers that
like really good common denominators or things that are divisible by 5.
Right. Pick numbers that are going to multiply well times that denominator of 5. All right. Is that good enough, or do we need to walk through those? If everybody's okay with that, we'll move on to the next. Okay. Okay. All right. Next. Yeah, you know, your test is what, 12 problems. You got, you know, some will be short, perhaps, but you got to keep moving, right? What if I gave you one then? Oh, let's do, what if you got an equation, you have to graph it. You get to pick whatever technique you want to use to graph. Here's another one like you might see. Graph those 2 equations. Now, back at the beginning of this chapter, our first technique was to do what we just did. Find some solution, plug in some numbers. By the time we've gotten this far, hopefully you recognize that form and you maybe have better techniques, easier, faster techniques. Like, oh, that's that version that has lots of good information and I can use to just start putting some points on that graph. This is one of those that is in that other shape. You have the option of rearranging it perhaps to put it in this shape if you'd like. But this is one of those where I have tried to suggest using the intercepts, plugging in the 0 for x and find the y and vice versa. All right. So if somebody wanted to graph that one, how would you approach that? Do you know what I'm getting at by saying this one is in this shape? So I know the intercept value and I know the slope value. That's supposed to be a B, not a 6, right?
Sorry, real quick. I like to write these as examples, as questions. How would you word this problem if you were to put that into words? Find the intercept values of
This is more likely to say simply graph this equation, use your favorite method. Or not
Okay.
what method, graph this equation. So then it's up to you to decide what techniques do I have.
Okay.
Yeah. So like I was getting at, I would hope that you're comfortable enough with the slope intercept form that you'd recognize that's the y-intercept value. 1, 2, 3, 4. The slope value tells me that if I go over 3 up 2 from the starting point, a known point, I can find a second point. That's all I need is 2 points. All right? That's the idea. I keep saying I hope, okay? But over 3, 1, 2, 3, and 1, 2, there's a second point. Always got to start from one, And I'll fix it if you do something weird, but mom only wants 2 points. If you do too many points, then it starts thinking you did 2 different lines, even if they're connected or something. I can fix it if it starts marking things wrong, but just get 2 points on there. This one, is that technique. This is finding the intercepts, 4.3, graphing using the intercepts. If I put in a 0 for x, do that, and I think I would get, if I just do this, I say, I think I get -3. If I put in a 0 for y, I think I get 4. Those would be ordered pairs. Are there any issues with that? Do you want me to do a little more work there? Or does that make sense? Okay. Now, I'm just going to kind of keep going. Stop me if necessary. Now, if you've got your 2 points then somehow like this, make sure you get your x's and your y's correct, right? 0, -3, 1, 2, 3, 4, 0. Don't mix up your x's and y's. That'd be too bad. So there would be an approach to graphing those 2 different shapes that we have worked with. Ready? Here goes. How about graph those 2? All right, those are those weird ones, special cases, whatever. If I could just drill this in, all this in your head, right? That'd be great, wouldn't it? But this is that situation you got to decide, oh, is this, I recognize it's those unusual, real simple looking equations, and one is the horizontal and one is the vertical. Which one's which? Y is always 3. Y is always 3. This is the one where don't try to put too many dots on the graph, okay? Just pick 2 points where y is a 3. X is always -2. Means y could be anything, but x is always -2. That's got a little messy, sorry, but there's your lines. Are there any issues there? Horizontal, vertical. Sounds good. Nobody's waiting to get in. Good. Oh, let's see. couple steps. What would the slope of a line parallel to this be? All right. The next one is I'm going to cross out parallel and put in perpendicular. So the point of this one is, well, I'm not sure what the slope is just by looking at it yet. I think you've got to rearrange it so it's in slope intercept. So you can figure out what is the slope I have to refer to. Okay. So I'm encouraging you to do that right now. Rearrange this equation. Put it in mx plus b shape so you can see the m slope value. You know, as always, you can go this way or you can go that way. I usually leave the y's alone and I move the x's. And then I have to get rid of the number on the y. I'd have to divide by -5. Okay, I'm thinking you should be this far, you'd be pretty well done, pretty close to done with this. I'm going to subtract the x's from both sides, which means -2x plus still the 10. I'm going to divide by the -5. Every piece divided by -5 gets me this here, y equals negative, now +2/5 x minus 2. Now there is the same original line rearranged and put in slope intercept form. Now you should be able to answer that question. What slope are you going to use if you try to come up with a line parallel to that? The slope you want is, you have to know that parallel is the same slope. So if you get this far and you see this is the starting slope here, parallel slope is the same slope. That one okay? Before I switch, right? Everything okay there? Let's use the same equation, and then in the interest of time, right, we do the same work. What if I had written this as perpendicular? Perpendicular. What would the slope of a line perpendicular to this one be? If you were faced with this situation, you'd still want to do this. So you can see what slope the starting line has. But then you have to remember that relationship. So somebody posted, I have to remember it changes this way and that way, right? That's right, it's two different switches, all right? Perpendicular slope, two changes to the original slope. Opposite sign, which we usually say negative of whatever it's there, or opposite of opposite, you know, if it was negative, it'd become positive. Opposite sign and reciprocal. The slope you'd want to be -5/2. So a line perpendicular to this one would have that slope. You know, hopefully it kind of makes obvious sense that if one of them is going uphill, the other one would have to be going downhill, right? But it also needs that specific reciprocal relationship to get exactly perpendicular. Plus and minus, opposite signs. Good enough? Okay. So, write the equation, or what's the slope of the line? Find the What is the slope? I think it's Kayla wants to get me to write these out. What is the slope?
Thank you.
Not a problem. And I'm not trying to just pick on anybody there. What is the slope of the line through these points? Something like that, I would say, right? Question. What is the slope of the line? So this is asking you to use the slope formula. Got to know that one. Not likely given to you. You got to know which ones go on top, which ones go on the bottom. Rise over run. Change in Y or change in X. You know, if you're cramming right before the test, you can stick, you know, as soon as you start, write it down. Or maybe it's in your notes. It's in your notes because you're, anyway. I assume you have these kinds of things handy while you're taking your test. You have your notes. Where is that one? So, got to have access or know the formula. Now plug the numbers in. It doesn't matter. The signs always work themselves out. But make sure you get your Y values on top. And sometimes you get minus, minus. Who's got a slope number for us?
I got 4 minus -7 over -1 minus 3. And that made -11 over 4.
11 over?
-11 over 4.
Oh, now let's see. 4, the way you said it, 4 minus a -7 is 4 plus 7 is positive 11.
Yeah, well, sorry, 11 over -4. Sorry, is how I should have said it.
Well, I think you still get this negative fraction. So
Yes.
whichever way you do it, you know, you just be careful. Anybody issues there? That process. All right. Sounds good. All right. Here we go. Now I'm going to try to make this clear or big, all right? What is the slope of the line? Now this is assuming, gee, I get to look at the graph and just count the squares. Now, I've tried to caution to always be careful to look at the units. Now I'm just saying these are all ones. So here's 1, 2, 3, and here's 1, 2, 3, 4, 5. So that should be enough information for you to count squares and come up with a slope. Is it going to be positive or negative? That should be a real quick one. All right, going downhill. If you think from here, how many Y's did I change to get to this one? Just counting the squares, right? I went down 5. And how many X's did I change to go from here over to here? 1, 2, 3. Right, so just using, look for good intersection points. Now I don't have a grid, total grid, so I used those intercepts, and so I'm going to follow up with what are the X and Y intercepts, right, as ordered pairs. And mom usually does something like, okay, X-intercept is, you know, and then you need to fill it in. So you got to get the right one in the right place. Don't mix up. That's supposed to look like an X. And the Y-intercept And then you have to write the ordered pair. And so since I kind of made my numbers big, hopefully that's not hard to figure out the values, but you just got to make sure you get the X and the Y and the right one, right? X-intercept is where it crosses the X-axis. Oh, that's this one. X and then Y, right? What's the X value? 1, 2, 3, oh, 3, 0 as an ordered pair. Y-intercept crosses the Y-axis up here. X is 0, but we're up at 5. Okay. Yeah, we calculated the slope, we found some intercepts, we read the graph to get the slopes and intercepts. Good enough? All right, then we write some equations. Write the equation of the line with slope 4 through the point 0, -1. For writing equations, eventually, we always need a slope and a point to work from. It'll say, put your final answer in slope-intercept form. It might not say that, it might not show that, it might just say slope-intercept form, which you have to know means that shape. Excuse me. No. I rarely use the word easy, but this is supposed to be the easy one. Why? Because you know the slope, and there's something special about that point I gave you. Because the X is 0, that means that is the Y-intercept value. I gave you the slope. I gave you the Y-intercept. That's your big, you want to, hope you get lucky there. Can't say you will, but so slope 4, oh, there's my slope. Y-intercept of -1. That might be a quick one if you get that kind of information. So you really do want to look for that to see if it happens to be the Y-intercept. But otherwise, I think save you time, right? So is that okay? All right, going to do another one here. Similar kind of problem. All right, similar wording, but this time I told you a slope and not the intercept point. So you gotta choose. Remember, we kind of had two versions, two techniques. And I guess, kind of hope maybe you've decided that one is easier for you than the other. Remember, there's one where I said, here's where we have to solve for the B value is one way, or you need to have in your notes or somewhere the point slope formula. So you could plug in to that. And then again, your instructions will tell you to present your answer in slope-intercept form. So either way, you know, if you do that, you got to do the work to put it in the other shape. Squeeze it in there. All right. So for both techniques, you're going to plug into whichever mold or form that you choose to use, I have to do a little work. If I'm going to solve for B, that's using the slope-intercept form to start. All right. Plug in the x and the y and the slope. Make sure you get your x's and y's in the correct location, right? 5 is the y. -2 times 4 plus b. That would be the solving for B method. And if I add that 8 to both sides, I get 13 is my y-intercept. We should get that over here. Similarly, right here, I'm going to, first step is to substitute what I know into the form that I'm choosing to use. Again, make sure you get your y value. That negative is part of the formula, so now put in the y number, and if it happened to be a negative, you could say negative, negative, or you could say plus. And what's this? -2 times x minus 4. Does that look okay? So that's the substituting the values in that I know. And then you have to simplify to get to here. It always involves distributing, right? -2x minus minus is plus 8. And now if I add the 5 to the other side, I'm going to put it in the middle for both of them. There's the equation using either technique. Funny looking 13. You will have to use one or the other. You will have this kind of problem. You've got to know how to deal with a slope and a point that's not the intercept. Got to be ready for that. Okay. That okay? All right. I'm going to pick some numbers that hopefully the numbers will work out nicely for you. But here, this would be one that might take up just a little longer because you still have to use one of those previous techniques, but you got to calculate the slope first yourself. All right. Going to use up your 5 minutes on this one probably, huh? I'll wait for this one, all right? I'll stop for a bit, get out of the way. Yeah, good. This one was on that practice test that I posted in the forum. So that way I know it's got good numbers for you. If you're still working on your week 8 hand-in homework, I encourage you to look at my post in the forum from last week about those problems, just kind of giving you some hints. I also offered, some extra credit points on the first one, if, because it didn't ask you to, I think it was interpret the slope or identify intercept, something like that. I wrote out, here's a couple more kinds of things that could be asked about this question. If you want to add those answers, I'll give you extra, I add a couple points to it. So,
if we've already turned in our hand-in homework, can we fix it and then resubmit it?
Yeah, actually, I think there's slots there. You could hand in 5 different versions. Just add.
Okay, that's great. I'll do that. Thank you.
Yeah, take a look at that, and it's just it's review, getting you to think about it more. All right. So you, yeah, I almost wrote that. I forgot to come back to that. Turn it in again. Yeah, so assuming you got full credit on this one, I'd go back and look for one where you maybe got a couple points off, and I'd add the points back in for you, hand in homework someplace if you want to add a couple extra questions.
I have to go. Is that okay?
You have to go. That's totally okay. And if you have questions, I'll be checking in.
I will definitely contact you if I have questions.
Is that Kayleen? Hi. All right. Take care. I'll see you later. Good luck tomorrow. Yeah.
Bye-bye.
Bye. All right. So slope first. Who's got a slope number for us?
I think I do. I got a -3/2.
-3/2. Anybody have issues with that? I think that's what I got too.
Okay, well that makes me feel good.
All right. Anybody have a problem with that? Now, once you've done that, you've found the slope that you are going to use. And notice I gave you a fraction slope, but the 2 is going to work nicely with both of those x's, and you have to simplify one way or another. Now you're going to use one of those other techniques, solve for b or plug into slope, point slope form and simplify to find that equation. Should we keep going and do this? Finish it up? You want to finish it up? Or should we move on?
Yeah, you can keep going. I would love to finish it up.
Finish that problem. Go ahead. Is what I meant? Finish that problem.
Oh, you want me to finish it? Oh.
Oh, I'm sorry. No, not at all. I'm talking to the class in general. You seem to be the one who's willing to speak up, but so that's good. Speak for everybody.
Okay, yes, we would all like for you to finish the problem.
Want me to finish it, or should I wait for you?
I mean, I would like for you to do it so I can see if my answer is correct inevitably.
Right. I'm trying to avoid not jumping in and just doing it while you are doing it up yourself. So that's why I'm being careful about that. Let's do this technique. Solve for b. I'm going to put it, make sure you get, that's got to be the y equals that, right? Slope I came up with times the x value of -2. There's my parentheses because of the negative sign. And there. So now I'm going to simplify that. Now that's negative times negative will be positive. The 2's I could say cancel out, like 2/1, right? And so this is just +3 plus b. Subtract. I get a b value of 3. Is that all right?
Yeah, so the equation would be y equals -3/2x plus 3.
Yep. Is there anybody who's really using that other technique and wants me to go through that? Yes, please. I like the other one. Yeah, that's why for years for quite a while we've been offering or teaching the solve for b technique, but like I said, the first time I did that, I always still see somebody who did it more or less on their own or looked at the book or something and they used that other formula, used that other technique. So if that's good enough, we'll leave it at that. Thank you, Kayla. All right.
Yes, let's move along.
Pardon? Huh?
I said yes, we're all ready to move along.
All right, he talks too much. All right. Write the equation of the horizontal line that goes through the point 7, -1. Horizontal line. Oh, that's one of those weird equations, simple ones, whatever. I use weird, right? Horizontal. what's always the same, the y or the x? Horizontal, it's always at that same y level. Horizontal line. If you're thinking it through, which part's always the same? Horizontal, it's always the y, same y. So this answer is going to be y equals something. Well, if it's going through that point and y is always the same, what's that y value going to be? -1. If it's going through that point and it's horizontal, it's always -1, no matter where else the x value might be. If I turn it around, this problem, right? What's the equation of the vertical line through the same point? What's the equation of the vertical line that goes through that point? Vertical. The x is always the same for all the different y's. X is the same number. This is a point that's on that same line. What's the x number? There's the vertical line. Okay. And good enough. Here we go. Yeah, notice it. That one they wouldn't ask you to put it in slope intercept form because the x one, the vertical one can't be, and the other one technically you could say is slope intercept where the slope is 0, so you don't even see it. But yeah, don't worry about it. Let's see. You might see something sort of combination. Remember, I asked you questions. What would be the slope of a line parallel to this one, or what would be the slope of a line perpendicular to this one? And then we did problems. Write the equation of the line parallel to through some other point. So this is a combination of understanding what it means to be parallel so that you can get a slope value. And then you're going to only use that slope. Don't do anything else with that equation. Use the slope you've determined. And then the point that you're told to use, solve for B. All right, solve for B. Are you okay with the process? We've done that a couple of times, or should I finish it up?
These take a little bit more time for me, so I just need like a couple more moments.
All right, you want to do it. Good, good, good. It's just like a couple of others, so I wasn't sure if you wanted to finish it up or not. I think I can pretty much guarantee that if you had a similar question asking you to do parallel, I like that, parallel to, if you had a question asking you for perpendicular, the slope would, you have to use a reciprocal. So the slope would work nicely with the point is what I'm getting at. If you had a fraction to work with, you should get decent numbers to have to work alongside it. So
I got y equals 7x minus 11.
I haven't done this one, so 7x definitely. Minus 11 or plus?
I got minus 11.
Anybody else want to confirm that? Just give me a nod or something. Yeah, is that a yes? Anyway, yeah, subtract, I get negative 11 is the B value. So I like that, okay?
Okay, great.
Yeah, yep. All right, and Yeah.
Are we going to do a perpendicular one next? Because those were the ones that were giving me trouble last week, and I finally figured out my issue. I couldn't get over that they were a opposite reciprocal. I didn't realize that. I kept going, well, why is it like this? I just thought it was a regular reciprocal. Oh my goodness, these had me so turned around last week.
It's like, what am I not saying right? She doesn't get it. I know. I kind of.
The light bulb just like went on suddenly, and I was like, oh my gosh, not only am I confusing this for parallel, but I'm doing the opposite reciprocal wrong.
I was under the weather a bit last week, and I felt like I was, well, I hope I didn't get too frustrated or anything like that for you guys. You know, it's just I could tell, oops, I'm reacting. Hope I didn't get in the way last week. Anyway, here we go. So, perpendicular to that line, I've abbreviated my sentence. I hope you're okay with that. Perpendicular to that equation going through that point. So again, you have to decide what the slope is going to be. Right, two changes. Change the sign and reciprocal. Change the sign means this will go to negative. I keep doing positive first numbers, but I hope you understand if it started negative, then you have to change it to positive. So it's always the opposite sign. Reciprocal 1/3. I did that on purpose.
So that's exactly what I got. And then when I did the problem, I'm hoping to go over this with you just because I got 0 for B. So I'd like to make sure I did it right. So I wrote it out, -2 equals, the -1/3 times 6/1 plus B. And then I reduced, and I got -2 equals -2 plus B. Of course, those cancel each other out. And then, yeah. So inevitably, I got Y equals -1/3x plus 0.
Yeah, and you don't even need the 0, but yeah, there's just, I made up the numbers. It's just a coincidence that it turned out to be 0, but 0 is a y-intercept. Means it's, it's going through the origin. Yes, it could happen.
Thank God I got it right.
All right, you're done. The test is over now. Wouldn't that be nice, right? Okay.
You all heard it. He said it.
Yeah, let's see. All right, Alpine College. I'm going to take this one just so the numbers work out, right? This is off that practice test. Alpine College raising tuition. Colleges don't do that. Ha! Raises tuition $25 per credit every year since 2000. One of your classmates asked me a question, I think it's in the Farrell Forum, about one of the homework problems that might have been 4.6 that was based on years since a given time. So that's not unusual when you're dealing with how many years since a certain point. So you still need more information. If each credit, right? This is on that other sheet. If each credit cost $375 in 2000, write the equation for cost. Here we go. In terms of years since 2000. And I'm emphasizing that. So what this is all about is saying if it's since 2000, and we know the value in 2000, that's times 0. You're not going to plug a 2000 in for your equation. You're going to say, oh, this is the y-intercept year. So from this information, that's what you want to recognize. If it's saying like calculate since that year. So in that year, that was when time was 0 and whatever the value is there, that's your y-intercept. This is telling us we know our y-intercept value right there. Let that sink in a bit. Or hope that, if that doesn't make sense, see if I can explain it, say it any other way. And so there's your y-intercept. College raises tuition 25 per credit. Right, there's your like clue for, oh, there's the slope number per cost per credit, right? Find in each credit, write the equation for cost. C equals, in terms of years, be careful. It's unfortunate when I see people not read slowly enough, I guess. Be sure you use the correct variable. Maybe it's a T for time, W for width, remember that, you know. It might tell you which variables to use. You might have all the right numbers, which means they give you mostly the partial credit, a lot of partial credit, but you didn't use the right variable. So, slope, y-intercept, or 375 plus 25 per year. You know, you could right, switch the order there. That doesn't really matter. Start at this and then add more per year. B plus MX. All right, if that's the equation, what does the equation predict the cost should be in 2020? All right, what's the cost in 2020? All right, so this is a situation where you're still counting since 2000, but the years are the time numbers, right? The T or the X here in my case, right? The years are the, so you're going to plug in a number for the X, but you don't want to put in 2020. You got to count since 2000, that's an X of 20. So C equals 25 times 20 plus 375. That's what that's getting at. So that's not an uncommon kind of follow-up question. Once you've got your equation, now use it. All right. And then, of course, that's just a, what's that for? $750 a credit, or $775 a credit? Yuck. Or a quarter of 20 is 500, it's 875. Wrong mental math. So that was that last one. About out of time, let me just, a similar situation, right? What if a value, you might still get a, I think that's what the particular problem that was asked about in Mom, that I posted about, but maybe a particular problem has a negative slope where a value is decreasing over time. And then you're able to get a slope value and an intercept value perhaps, and you can write your equation, but a follow-up equation might be, a follow-up question might be one that says, when do you run out? When do you get to 0 here? That means your final value is 0, and then you'll have, you know, whatever the rest of your equation is. I've just made something up here, you know. Means I started at 15,000, but I'm losing 100 a year. When does it get to a final value of 0? Here, you're not given an X value or a time, you're given the outcome. How long would it take to get to 0? Okay. I see that we are out of time. So as always, encourage you to go through those reviews that I really today kind of worked off of that optional one I put in the forum last week. I called it a practice test. I kind of worked off of that, but made up different problems today. But that would be another good on-paper review for you if you're looking for that. And I'll be checking in later if you're working on something and you get stuck, including the 4.4, 4.5, 4.6, and your homework week 8 that are due tonight. Get all your review and homework done, ready to go for tomorrow. Okay, folks, that's it for today.
Thank you.
You're welcome. Good luck. The usual routine for tomorrow's test. Okay, see ya.